Another type of method used in study of brain is histological methods. With the advent of technology in the present times, there are many techniques and methods to study anatomy and functioning of human brain. For studying minute details of tissue, microscopic investigation, histological methods are used for the purpose. In this method, the sample of the brain that is under investigation needs to be prepared so that it can be mounted on a slide and observed under a light microscope. The neural tissue is very fragile and under normal conditions it may just disintegrate. Hence, the tissue needs to be fixed and stained in order to be viewed on the slide. When it is taken out, the bacteria or molds tend to decompose the neural tissue. Let us now look at the procedures in histological methods. Fixation, freezing, embedding, and staining. Let us look at each one of them in the upcoming slides. Fixation. In this method, a fixative is used to fix the tissue. The tissue is cleaned and dipped in a fixative solution. The most commonly used fixative is formalin. This fixative prevents autolysis and makes the tissue hard. In biology, autolysis, or more commonly known as self-digestion, refers to the destruction of a cell through the action of its own enzymes. It may also refer to the digestion of an enzyme by another molecule of the same enzyme. The term derives from the Greek auto, that is self, and lysis, that is splitting. But still, the tissue is not so hard to be cut using a microtome. Hence, the brain tissue is freezed so that the tissue becomes more hard. We will learn freezing in next slide. It is also used to stabilize the neural tissue. Now, microtome is an automatic slicing machine used in the microscopy to produce thin sections of the fixed and embedded tissue for microscopic observations. Freezing. In freezing, the tissue needs to be frozen in order to be sliced. To freeze the tissue, it is dipped in a sugar solution and then put in a freezer. The temperature is regulated in a way so that the tissue is maintained at an appropriate temperature. Once the tissue is hard enough, it is to be placed on the microtome to be sliced. Embedding. Another way to make the brain tissue hard is by embedding and covering it by paraffin and nitrocellulose. Once the tissue is hard, then it is cut using a microtome. These slices are then placed on a slide and mounted on it using albumin, which is taken from the egg. The slide is dried. It is then dyed using different chemical solutions. Staining. It is done so that the structural details of the tissue becomes apparent under the microscope. This is done by darkening or coloring particular features of the tissue. Nissl stains or cell body stains are most frequently used to dye the cell bodies. On your top right, you can see two neurons with well-stained Nissl bodies are indicated by arrows. Nissl is typo in IGNOU material. It's not Nissl, but it's Nissl, a technique named after Franz Alexander Nissl, who was a German psychiatrist and medical researcher. He was a noted neuropathologist too. Myelin stains color the myelin sheath to study the nerve pathways. On your bottom right, you can see trichrome staining of the right phrenic nerve showing preservations of myelinic sheath. Membrane stains like Golgi-Cox stain helps to color the cell body, dendrites and axons.